Components of the vector AB. Remember, AB is B minus A. So that's minus 1, 3, 2. It's a column vector. Minus 3, 2, 4. Minus 1 minus minus 3 is 2. 3 take away 2 is 1. And 2 take away 4 is minus 2. Part B asks us to work out the magnitude of the vector AB. So we square the 2, square the 1, square the negative 2, add them all together and take the square root of the total. Square root of 9 is 3. Question 56, we've got to work out the sizes of the different angles. What I'm going to do is this is a radius here, and this is a radius here, which means the triangle is isosceles. 180 take away 78 is 102, divided by 2 is 51. So this angle here is 51, and this angle here is 51. Now, different things we can do. This angle here is a 90-degree angle because the triangle is drawn inside a semicircle, and such a triangle is right-angled. So 51 plus 39 degrees gives us 90 degrees. This is a radius and this is a radius, so this angle in here must be 39 degrees as well. The triangle is isosceles. 39 and 39 give us 78. 78 from 180 is 102 degrees. Now if we move on to this angle here, 180 take away 51 is 129 degrees. 1, 2, 9 degrees. If you look up here, what we have, this line is a tangent. A tangent meets the radius at 90 degrees, so this angle here is a 90-degree angle, which means that this part of the angle is 39 degrees. So that's 39 degrees in there. The triangle, there's only one angle left to find, that's this one here. So 129 plus 39, that equals 168 degrees. 168 plus 12 degrees gives us all the angles that we need. So we could state explicitly what A, angle OAD, that was the last one that I found, that's 12 degrees. Part B, angle ADB, that's 39 degrees. And angle C, angle DCB, DCB is also 39 degrees. We're told here that the radius of the internal radius is 10 centimeters, which means that this distance here is 10 centimeters. Now, you should be reasonably familiar with problems of this sort. I'm going to draw a line down there. We already know that the bottom part is 4, so this part here must be 6, because 6 plus 4 gives us 10. And this line down to the bottom of the water is also a radius. What I'm going to do next is to mark a right angle in here, and then an X in this position here. These questions involve Pythagoras. So it's a shorter side calculation. X squared equals 10 squared take away 6 squared. 100 take away 36 is 64, and the square root of 64 is 8. Now, so to get the full width AB, it's 2 lots of 8, which is 16, and the dimensions are centimetres. We want to change the subject of the formula to t. The first thing to do is to isolate this term here, and I'm going to do that by subtracting b from both sides. A minus b equals ct squared. Next thing to do is to get rid of the c. The c is multiplying the t squared. To get rid of a multiplying quantity, we divide. Now, how do I get rid of the square? I take the square root of both sides. So the square root of a minus b over c equals t. And I could turn it round so that t is at the front of the line. F plus v equals g. We want to solve each vector equation for v. What I can do then is subtract f from both sides. So v then equals g minus f. And now I can put in some numbers. G is 5 minus 2. Minus f is minus 143. And that gives v as 5 take away minus 1 is 6, 5 take away 4 is 1, minus 2 take away 3 is minus 5. We want to work out v. We don't need to move anything around, so it's 2 lots of f. And 1g. And that gives us minus 2 plus 5 is 3, 8 plus 5 is 13, and 6 minus 2 is 4. Does everyone hope you see where this is coming from? So it's 2 times minus 1, 2 times minus 1 plus 5, etc. So take away g from both sides. We have 2v equaling 3f minus g, divide by 2, so v equals 1/2 of 3f minus g, 1/2 of, now 3 lots of f give us what? 3 times minus 1 is minus 3, 3 times 4 is 12, and 3 times 3 is 9. Minus 5 minus 2, and we're going to multiply the result by 1/2. So minus 3 minus 5 is minus 8, 12 take away 5 is 7, and 9 minus minus 2 is 11. So half of minus 8 is minus 4. Half of 7, I'm going to write that as 7 over 2, and then 11 over 2. We could write the decimal 3.5. We could also have 5.5. Last question. What I want to do is to work out first thing we should realise is that this line AB is a tangent to the circle, and a tangent meeting the radius creates a 90-degree angle. So we've got a right angle triangle. We have an angle in that right angle triangle. We're going to use SOHCAHTOA to work out one of the missing sides. Now, which side are we going to work out? We're going to work out this side here, because that's the radius of the circle. So, I'm interested in calculating the opposite side. 13 is the adjacent, and you can see from the formula, or from the SOHCAHTOA, that it's the tan ratio. So tan of 25 degrees equals CB over 13. I want to get CB on its own, so I'll have to get rid of the dividing 13. CB equals 13 tan 25 degrees, and that gives me 6.06 centimetres as the radius of the circle. I want to work out the area of the shape. What I'm going to do then is to calculate the area. Well, let's see. This angle here is 25 degrees. We know that this one's a 90-degree angle, so that leaves this one here as 65, which is very important. We're not going to use that 65 itself, but we are going to use this angle here, which is 360 minus 65, and that equals 295 degrees. That's very important. So that is 295 degrees. I'm going to calculate the area of this triangle. It's a right angle triangle, so the area is half the base times the height, 1/2 of 13 times 6.06. That's 39.4 centimetres squared. So that's this shaded area here. What I'm going to do now is to work out the area of this part, which is a sector of the circle. And the formula is area equals angle over 360 times pi r squared. So it's 295 over 360 multiplied by pi multiplied by the radius, which is 6.06 all squared. And we get a total of 94.54 centimetres squared. So the total area is 39.4 plus 94.54, and that gives us 133.94 cm squared.